Black math! Give me some math and I'll give you some flack. Black math!
All right.
Just think about how we're not ready.
This will be all right. We did a little bit of this. If you were in geometry, you did quite a bit of this. But we're going to talk about trig functions and their reciprocals. This is one of those really easy concepts that's just hard to remember what goes with what and things like that. So don't stress trig functions and their reciprocals. So trigonometric is actually the word, which is really fun to say. Trigonometric. It's nice. Okay. So there is a little acronym that's pretty easy that most people will remember. It's Sohcahtoa. Sohcahtoa. So sine, the sine function is just a ratio. So in every right triangle, there are ratios. So the sine in every right triangle, the sine of an angle equals the opposite side divided by or over the hypotenuse. So if I had a right triangle here, and this was an angle, we're going to call it theta. So in trigonometry, we ran out of the English letters, so now we're starting to use Greek letters. This is theta. You guys have, if you're in physics, then you're at least going to start to get familiar with this. So this is nice. If you're in physics now, then physics will be easier for you now. Okay. But this is theta. It looks like it may be like a 40-ish degree angle, but it doesn't matter. So in every right triangle, remember there's two legs and one hypotenuse. So sine of theta is going to be this guy. So if this is A, B, and C, the sine of theta, which is abbreviated SIN, not SINE, sine of theta equals A, so the side opposite of the angle over the hypotenuse. The hypotenuse never changes. So the hypotenuse never changes, but if I wanted to take the sine of this angle, then it would be opposite, which opposite that angle is not A anymore. Now it's B over hypotenuse. So the hypotenuse always stays the same. So the hypotenuse is always the hypotenuse, but the opposite side is relative to what angle you're talking about. Okay? So it's across the pond. See how it kind of makes sense? You've got three choices to pick on which one is the opposite. Well, it's not going to be the two that are connected to the angle. It's going to be opposite the pond, on the other side of the pond, okay? Cosine. And this is abbreviated just COS, is adjacent over hypotenuse. So adjacent is also relative. Adjacent over hypotenuse. So the adjacent side to theta is the side that's touching that angle. That's not the hypotenuse, okay? So it's B over C because it's adjacent. So not C because that's the hypotenuse. So B over hypotenuse. Okay, so I'm going to just put a little note here. An adjacent side, it's the leg touching the angle, or a leg that's part of the angle. So adjacent's kind of a weird word, but there's not really a lot of words you can choose for this. But it's the included, maybe they should have said included side of that angle. Leg of the angle. Okay? So see how there's a leg of this angle and there's a hypotenuse of the angle. So there's two legs of an angle. One of them is a leg and one of them is the hypotenuse. Okay? If that's not the case, then you're dealing with this angle, and you'll never do trigonometric functions on the right angle. okay? Because that's 90 degrees, it just doesn't work, okay? So the adjacent angle is the leg that's not the hypotenuse, or the leg that's a part of the angle, yeah. So this is a good way to describe it, leg of the angle you're talking about. So the cosine of this angle would be what over what?
B over.
So that would be the sine of this angle.
C over B. Or wait,
Oh, adjacent A over B.
Yeah, so A is the leg of that angle over hypotenuse. So do you guys notice that the sine of this angle, B over C, is the same thing as the cosine of this angle? Okay, so you're going to have all these similar ratios depending on what angle you're talking about. Okay, and the last one, T, is tangent. And that equals opposite over adjacent. So the tan of theta, what is opposite theta? A, and what is adjacent of theta? B, so A over B. Okay, so the concept is easy, but trying to remember what goes with what is difficult, okay? So Sohcahtoa, see how this is a nice little acronym. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent, okay? Now it's not phonetically perfect, but if that helps, great. If not, when we take our next test, write that down on the top of your test before you take it, or right when you take it. So look at Sohcahtoa and then write that down. And then you should be able to come up with the ratios based on that acronym, okay? That's an easy adjacent or an acronym that could help you. All right, so let's rewind a little bit. This is basically the meat of the lesson, but trigonometry is basically the study of right triangles. Okay, now we do use trigonometry with triangles that aren't right triangles, but that's where trigonometry begins, is the study of right triangles. So a trigonometric ratio is the ratio of the lengths of any two sides of a right triangle. So whenever you have if this was like a 40-degree angle, no matter what the right triangle is, these ratios will be the same. So that 40-degree triangle, 40-degree angle in a right triangle, it will always, it's similar to any triangle that's 40 degrees. So if that was 100 times as big, the ratio would still be the same. They would be proportional. Okay? A function whose rule is a trigonometric ratio is a trigonometric function. Okay? Now these guys are on your calculator. If you got a 99-cent Walmart calculator, then it might not be, but on your phone, and especially your iPhone, if you do this, let me show you. I always keep my calculator on my control center or whatever, so I can just swipe down there. So here's the normal calculator, right? So if you go sideways,
you have to turn off the orientation.
what?
You have to turn off the lock portrait orientation.
Yeah, it's off, but it's being poopy. How dare you? There it is.
go.
Okay, so now we've got a bunch of trigonometric ratios that show up. You see the SIN, COS, and TAN. Those are there. And if you use your iPhone, it's a little different. Okay, are you guys talking about your calculators?
Yes.
Yeah. So if you have a Texas Instrument calculator or Casio, something like that, then those are going to be a lot more straightforward. So you can say sine of 40 equals boom, and it gives you this ratio. So a sine of a 40-degree angle will never change. It's a constant. So that's nice. So back in my day, we didn't use our calculators. Well, we had them on our calculators, but we had to use these tables. So we had charts of sine of a 40-degree angle, blah, blah. And then so it had columns, sine, cosine, tangent, and all that. And then it had like 40.1, 40.2, 40.3. So we had pages of these trigonometric ratios that we had to just look up instead of using our calculator. Okay, but calculator is nice. So that's a constant. Like some of these are pretty easy. Like some ratios, like a 60-degree angle. What is a 60-degree angle? That would be sine of a cosine of a 60-degree angle is 1/2 exactly, 0.5. But most of the time they are irrational numbers. Okay, most of the time they're tough. So so we talked about sine, cosine, tangent. All right, so let's just try an example. I'm going to draw a triangle, a right triangle here. I don't know if this is right. Would this be a right triangle? Let's see. Would this be a equivalent triangle to like a similar triangle to a 3, 4, 5 triangle?
I don't think so, 'cause
Yeah, if you divide them both all by 8, look, 3, 4, 5. That works. So that's a 3, 4, 5 similar triangle. It's a Pythagorean triplet, but that was just for fun. All right, so let's do this. Find the values of sine, cosine of, let's see, angle A. So find the sine of angle A, the cosine of angle A, and the tangent of angle A. So how do you find the sine again? Opposite over hypotenuse. Okay, what's opposite? Oh, I didn't give you letters.
Which one is angle A?
Well, good luck with that. Okay, so what's the sine of angle A?
32 over 40.
32 over 40. Opposite of angle A is 32. And the hypotenuse is always the same, 40. So we can reduce that to, what is it, 4/5? Or 0.8. That's a nice little number that doesn't give you an irrational number. That's cool. What about cosine of A? 24 over 40. So let's reduce that. So that's 3/5. Remember a 3, 4, 5 triangle. And then what about tan? 32 over 24. Good. So that's 4/3. All right. The next part is pretty brainless. It's not hard at all. They're just reciprocals of these. Okay? So there's 3 other trigonometric functions which you don't have to remember an acronym because they're just flipped over. All right?
What? I don't know if this sounds dumb, but like, what's the point of finding these?
Well, good question. Watch G.I. Joe.
Really?
There's a scene in the G.I. Joe movie where they use trigonometry to look at the sun, the shadow of the sun, what time a picture was taken, and the shadow of the sun that was cast. And then they were able to figure out where this person was in the world, type of thing. So they use trigonometry. Yes.
Can that be our homework instead of the problem set?
Yeah. Watching the G.I. Joe.
Watch G.I. Joe.
Yeah. G.I. Joe movie. When did that come out?
That's like, I think, was it The Rock? Wasn't The Rock in that too?
What?
I don't know if he was in the first. Yeah, it's a good movie. It's entertaining. It's not like
I really think we could
Marvel-ish, but it's a good one. I only saw that movie once, but I remember watching that and I'm like, oh my gosh, I have to use this in my math class type of thing. So yeah, you should watch it for sure.
But like, what does this tell you?
A G.I. Joe movie
Okay,
came out
good.
this year.
I'm still confused about like what this
Good
tells me.
question.
Really?
So,
Yeah.
in the past,
I'm surprised.
we could not figure out x until we knew the Pythagorean theorem, right?
Correct, yeah.
So now what we can do, now we can figure out what x is if we're given just one side. So we needed two sides to figure out the third side of a right triangle, right?
Mhm.
Now we just need one in one of the angles of a right triangle.
As long as it's not, but so technically,
So now we can figure out these other
you
two
can't
sides.
use the 90-degree angle. It has to be one of the other.
Right. Well, you already know it's 90. So if you know this is 30, this is 60. So if you're just given one of the angles in a right triangle and one of the sides, then you can figure out all six angles and sides of a triangle. Over here, Pythagorean theorem, if you're just given two sides, you can find the third, but you don't know what the other angles are. Okay. So trigonometry allows you to figure out all the components of a right triangle with less information. Okay. All right. I mean, that's basics. There's obviously, if you're a G.I. Joe, you have more use for it than.
Right, but the problem is I'm not a G.I. Joe.
Okay. Well,
I wish
not yet. Maybe.
I wish I was a G.I. Joe.
So there you go. So dream big. Okay. So three other trigonometric functions: cosecant, secant, and cotangent. Okay. So cosecant. This is where it gets a little frustrating. Cosecant is basically the inverse of sine. Secant, which starts with an S, is the inverse of a cosine, and then cotangent, that's easy to remember. That's the inverse of a tangent. So inverse meaning you flip it over. Okay, so they're just reciprocated. So cosecant is reciprocal of sine. So in other words, CSC of theta equals hypotenuse, hype over op. Okay, so all we did was flip it over. Now this will come in handy when you're trying to find the missing side and there's variables involved. These are, some of you say, well, why can't we just use this for everything? You can, but this will maybe save you a step in your equation. So I don't really use these at all. So you don't have to.
You can just, let's just flip it around, right?
Yeah,
So you can
it's
just find the sign and just flip it around.
right. So if I said the cosecant of A is just 5/4.
Right.
Okay. So see how these aren't really needed, but these might save you some time if you want to use them. Okay. But you need to know them for tests and stuff like that too. So let's just write it all out. Secant is the reciprocal of cosine. So see how that's a little frustrating.
I'm so confused.
Yep.
Why would they do that? Can we just pretend it's not
Because
like
I guess co is like flip the reciprocal, because cotangent is the reciprocal of tangent.
But that would make you think that cosine is the reciprocal of sine.
Yeah, I know. So they probably decided on these words like at 3 a.m. when they were trying to write their first trigonometric textbook.
Sine isn't to cosine as tangent is to cotangent.
Yeah, it's kind of inconsistent and frustrating. But the cotangent of an angle A is the reciprocal of the tangent. The secant of an angle is the reciprocal of the cosine. Okay?
the hardest part about this is just gonna be remembering the words.
Yep, you're right. You're right. So, and again, you can survive on these alone for now. Okay? So don't, unless it asks you specifically what those are, you might need to look back in your book or whatever. And if it's on a test, forget about it. That's easy because we're going to go over it anyway. Okay? So, for your homework, it might get a little annoying, but again, when you do homework and you have to research and go look up stuff, your brain's gonna eventually say, just remember it. Because I'm tired of going back and looking up stuff. So that's the whole point of rigor, guys. Rigor equals Saxon. Saxon equals rigor. So there's 120 problem sets. Problem set is 30. So how many problems in this book are there?
Too many is on
20 times 30.
120 times 30. So it's 3,600 problems. If you did every problem set, that's what you do. So I would say that you would do at least 1,000 this year. You're going to do at least 1,000, probably more.
How do you expect us to remember 1,000 problems?
No, you don't. You're not supposed to remember it.
Like
But
5 of them.
if your
It's the
brain
same
does
for
1,000 problems, then your brain is going to remember it. And here's what I mean by your brain remembering it is your muscle memory. Okay. So your muscle memory, so 8 plus 5, you know is 13. You're not counting on your fingers anymore. You're not counting on your fingers anymore. You know it's 8,
But
you
I
know
do
it's
have
13. Okay?
I do have a
All right. So let's do example 2. Example 2 says, find the values of cosecant, secant, and tangent of this triangle, ABC. So this is the equivalent of a 5, 12, 13 triplet. Okay, so find the cosecant of B, the secant of B, and the cotangent of B. So this is how I didn't mention that. The secant is just abbreviated SEC. Cosecant is COS or CSC, not COS, like it would be in cosine. Again, confusing. But CSC is the abbreviation for cosecant. SEC is the abbreviation for secant, and COT is the abbreviation for cotangent. So the only weird abbreviation in all of this is cosecant, because everything else is the first 3 letters. Sine, cosine, tangent, that's just the first 3 letters. But cosecant, you can't use COS again because you already used that abbreviation for cosine. So, all right, somebody over here, tell me the cosecant of B.
Maybe 10 over 26.
That would be exactly the sine.
Okay.
So remember cosecant, flip it over, so it's just 26 over 10.
Okay.
So you did opposite over hypotenuse.
Yeah.
Okay, which you did it perfectly. But the cosecant is the reciprocal. So 26 over 10, so you can reduce it to 13 over 5. Most of the time it's going to ask for a decimal answer or a rounded to the nearest hundredth or whatever like that. So you don't have to reduce it, obviously. You just put that in your calculator, bloop, and you're done. Okay? So then what about secant of B?
Wouldn't that be 26 over 24?
Yep, 26 over 24. And then what about the cotangent?
24 over 10. Yeah.
24 over 10, good. So adjacent over opposite. Okay, now, here's the other cool thing about trigonometry is now we can figure out those angles. Okay, so here's what you would do. On your calculator, you're basically saying that B, let's say B is theta, okay? So if I wanted to say, and I'm going to just use sine. So sine of theta equals, what is it, opposite over hypotenuse, so 10 over 26. Okay, now I can figure out theta. So what angle has this ratio? Well, if it was me, I would do that math, so 5/13 and get it to a decimal to the nearest like 10,000th or something like that. And then I would look it up in my charts until I found the number closest to that. Which angle has that? Well, on your calculator and on your iPhone especially, you can, you have to unlock your phone
Oh.
and then you can go sideways. So here's the cool thing is basically, I can solve this equation. So we're trying to find theta, right? So to find theta, you have to get theta by itself. So what's over on the left side that you have to get rid of?
Sine.
Sine. So what we do is called an inverse sine function, not an inverse sine, an inverse sine function. And I probably shouldn't have used the word inverse when I talked about these. These are the reciprocals of the trigonometric functions.
Lost.
Okay? But an inverse sine, so basically I want to know what angle, so it's like the opposite operation of sine is the inverse sine. So my calculator is going to figure out for me what angle has this ratio. Okay? So I'm going to apply, to get rid of that sine, I'm going to say inverse sine. And it's just sine to the -1. That's what it means. That's like an inverse function. Okay, whatever you do to one side, do to the other. This cancels. And now I'm left with this function, inverse sine of 1026. So on my iPhone, I would do 10 divided by 26. And I get this decimal number, 0.38461. Okay, so like in my book, I would look and try to find that decimal number and see what angle it was closest to. Okay, but here's what I'm going to do. I'm going to go and I'm not going to push sine. I don't want to press sine. I want to do the opposite of sine. So I'm going to hit my second button and then it changes everything. It puts a little -1 exponent after the sine, cosine, and tangent. On your Texas Instrument or Casio calculator, you're going to have the sine function, and then on top of it, you might see in green or a different color, sine to the -1. So that's what you want to do. And then I'm going to hit sine, and it's going to say 22.6198. So 22.62-ish. So that's roughly what that theta is, and that kind of looks right. That looks like a 22-ish degree angle. Okay, so we're going to do more of this later in this lesson. We're not doing the inverse functions yet, but we are finding the sides. Okay, so if we're given an angle and one of the sides, then we can use these functions forward, not backwards. Like this is going backwards. Don't worry about that. We're going to use it forward to find the missing sides. Okay. So let's look at example 3. So identify the known and unknown lengths of as the hypotenuse and the side to a given angle. Okay. So here's my first diagram. This is a 42-degree angle, and I have this side, 32. I want to find x. Okay? I want to find x. So the only angle I have right now is 42 degrees, but really I could say that this is 48, right? Because it has to add up to 180, or these two have to add up to 90. So I could use that angle, but let's just use what we're given. Okay, so here's what goes through in my head. All right, so if I look at this angle, the only sides that are kind of written down are the opposite side and the hypotenuse. So what's trigonometric function deals with opposite and the hypotenuse? Sine. So I could say sine of 42 equals what over what?
32. Sorry, x over 32.
X over 32. Now how do we solve for x? Yep.
32.
How do we get rid of 32? It's being divided, so times 32 times 32. So x equals 32 times sine of 42. Well, that's all doable on your calculator. So look at this. Get it off second. So all I'm going to do is say 42. Now on the iPhone, it's different because I have to find the sine of 42 first, 42, and then push the sine button. And it gives me 0.669. That's just the ratio. That's okay. Times 32 equals 21.41. Does that look like 21.41?
Sure.
And all these are going to be like, most of the time, you're not going to put equal signs. You're going to put approximation signs, which is just a squiggly equal sign. Okay. So write it out first. If you don't write it out, it's going to be a little confusing, and you have to, don't try to do this in your head. So you could have written, okay, the cosine of 42 degrees equals, well, we're not given the adjacent angle to the 42-degree angle, so the cosine doesn't really help us. Tangent of 42 degrees equals x over, we're not given that adjacent angle, so that doesn't really help us. So see how sine of 42 would be a good function to use. You could have used the cosine of 48 if you wanted to, but that's just more work for yourself. So use the angle that you're given, and the variable, so the variable is across from that angle, so we're going to use the opposite over hypotenuse. Okay. See if you guys can do this next one by yourself. So this is actually example 4. And this is a real life example here. The top of a Yaquina Bay lighthouse on the coast of Oregon is 162 feet above sea level. So let's see, here's the lighthouse. That's a terrible drawing, but whatever. There's a lighthouse. It's, how tall is it? 162 feet. So here's 162 feet. And lighthouse, if it was built correctly, it's going to stand straight up. If it's not, don't go in it. It's dangerous. None of this Leaning Tower of Pisa stuff. Okay, and the angle of elevation from a boat to the top of the lighthouse is 35 degrees. Okay, so here's what's happening. Here's a boat. And this is 35 degrees. See how this is the angle of elevation. This is the water. That's 162 feet high. Find the distance from the boat to the base of the lighthouse. So I want to know what this is. Okay? So what ratio do you think would be the best given this angle, this side, and this side?
It's the
Tangent.
Okay, yeah, so see how we're not given the hypotenuse? So if you're not given the hypotenuse, then sine and cosine doesn't really help you. So your choices, plural, are tangent and what else? Cotangent. So let's start with tangent. So tan of 35 is opposite over adjacent, so 162 over x. Okay, now this is fine, but see how it's a little bit trickier to get x by itself because it's in the bottom of a fraction. Well, if you did this step by step, you would have to multiply both sides by x, right? And then you'd have x times tan of 35. And then to get x by itself, you divide by tan of 35, and you have x equals 162 divided by tan of 35. See how that could be confusing. So the other option is your goal is to kind of make sure that your variable is reachable. This saves you more time in solving your equation. So the cotangent, remember, is just flip. So now my variable is on top. just where I like it. So how do you get rid of that 162? Multiply by 162. So now x is by itself. X equals, which is what you're trying to find, 162 times this constant. How do you find that constant? What do you do on your calculator? What kind of calculator do you have? So see if you can figure that out. So find x on your calculator.
Are we allowed to use our phones?
Yep, you can if you don't have your calculator with you. Make sure you try to keep your calculator with you as much as you can. But
What is tan H? Tan.
that's a little bit more of an advanced trigonometric function that you won't use this year.
So there's, yeah, because underneath sin, sin, cos, and tan
Yep.
is the sin, h,
So there's no
COH.
cotan button.
There isn't a cotan, but do you see the button underneath the second?
No,
It says 1 over x.
no.
Do you have that on your iPhone? On the second button? So right under the second button, there's a 1 over x button.
Oh, okay.
So if I said tangent of, or I have to say 35 first.
But what do? You go
35 tangent, and then I'm going to flip that over. So I just hit 1 over x.
1 over x.
How do you do it on a
Okay, so on that calculator, so you're just going to say, sorry. So you could just go, oh, x to the negative 1. That's 1 over x. So then after you find tangent of 35, then hit that x to the negative 1 button. You figure it out? Perfect. That's what I got. Yeah, did you guys get it? Do you have your do you have a calculator at home? Like your normal calculator?
Yeah, it doesn't work too well.
Okay, well you can use this.
I think mine definitely has it because I got a pretty good calculator, so mine has that.
Okay.
Mine has
So-
the sine,
what'd
the
you get?
cosine, and the
It
what's the
might
other?
have cotangent, it might
Yeah,
have those,
cotangent.
if it
It has
doesn't,
all
look
of
for this button,
Which one?
1 over x, that's it.
What did you
Or
get?
remember, 1 over x is the same thing as
That's
x to the
before you
negative 1.
multiply it by
So on
6.
Delaney's calculator, there's an x to the negative 1
Wait,
button.
you have to multiply by
So I have to do
Or, yeah,
45,
Okay, so you have, okay. got it.
35,
So yeah, you were.
and then I hit the regular tangent. It gives me that number, and then I hit the 1 over x, and that's the number I'm looking for.
Okay,
So then that is multiplied by 162,
okay.
and then you're done.
I got cool. I got that.
So what'd you guys get?
231.35.
231 point a bunch of.
So you can say, if they don't tell you where to round, the nearest hundredth is always a safe spot. So it'd be 231.36-ish, right? All right, so x is approximately 231 point, what is it, 36-ish?
Yeah.
Okay, and then make sure, because remember, Saxon will never draw a bad diagram. The diagram will always be pretty good. So make sure it makes sense. So 231, oh yeah, it's longer than 162. That kind of makes sense. Okay. Now, what if it said B, find the hypotenuse, find the length of the beam of the light to the boat. How do you do that?
Would you do? You could use either the sin or the cosine.
Cosine.
Yep.
Well, not cosine,
Cosine, right?
Yeah.
cosecant.
So here's the deal. You have like 3 or 4 more different choices.
Yeah, because you could use the
Technically, you could use
the cosine or the.
cosine.
Oh my gosh, I'm so confused.
That's all right.
Well, I know what I want to say, but I don't know what.
That's all right. You just have a lot of sin in your life, apparently.
I do.
So you could also use what? You could use secant. What else?
Cosecant.
So
I'm not saying that.
don't think about trigonometry for a second. What else could you use?
Oh, since we know the,
Oh, we could use the
since we know
sine
x, we can
Yep.
just,
So Pythagorean Theorem, you could find the third side. Since now you know 2 out of the 3 sides, you could use Pythagorean Theorem. Okay? Cool. Awesome. So should we do that? Is
if you already know x.
So this, you guys think you can handle these kind of problems?
Yeah.
And
Yeah.
if you need, just look at your solutions manual to get a little bit extra help starting that first problem or 2, but then just try to wean yourself with that and see if you can do these on your own. Okay? Good? All right.
Black man.